Hi everybody. So what I'd like you to do is go ahead, we're going to be multiplying, dividing, and simplifying radicals today. I'd like you to go ahead and do the first 8 on the top of the page, and I'm going to just make sure you feel comfortable with them and check those tomorrow. But what we're going to be doing today is we're going to be multiplying rational expressions. And so in the past, what we've been doing is we've been reducing radicals by breaking them apart into the largest perfect squares. But sometimes we can simplify easier if we multiply them. So for example, if I look at example A, I see 2x cubed and 8 times 8x cubed. And neither of them are perfect squares, and the x cubes are both odd, which can be really, really crazy. So the best thing to do in this case is to notice that if you multiply 8 times 2, you actually get 16, which is a perfect square. And if you multiply x cubed times x cubed, you get x to the 6th, which is an even square, which we know how to deal with. So now we can simplify and you're going to get 4x cubed, okay? All right, moving on, let's try another example. 12x cubed y squared times 3x squared y to the 6th. So what I always do is I make sure none of them are perfect squares, and I see if I multiply them if I'm going to get a perfect square. In this case, I will. So I'm going to get 36, so the square root of 36, x to the 5th, y to the 8th. All right, got to do some work here. The square root of 36 is 6. The square root of x to the 5th is x to the 4th times 1, so it becomes x squared, and there's going to be an x left in the root. Y to the 8th is odd, so we take 8, we divide it by 2, and we get y to the 4th, which comes out as comes outside of the radical. So 6x squared, y to the 4th, root x. Okay, moving on. It can get a little harder when I look at ones that have numbers on the outside. So this actually is read 3 root 2 times 4 root 18. So the first thing I'm going to do is I'm going to multiply the whole number. So I'm going to multiply 3 times 4, which is 12. And then root 2 times root 18 is root 36. Look how nicely that gave me a perfect square. And so now I can simplify that to 12 times 6, which then is 72. Okay, and there's my answer. All right, let's try this last one. I see the numbers on the outside. I have to multiply them. So 5 times 8 gives me 40. Root 3 times root 21 gives me root 63. Okay, now I do have to simplify 63 by finding the largest perfect square in it. By this point, I think you're starting to see that the largest perfect square in 63 is 9. So it becomes 40. 63 becomes root 9 times root 7, which then is 40 times 3 root 7. So then my final answer would be 120 root 7. All right, let's move on. All right, dividing. So always see if you can divide the numbers first before we do anything. That should be step 1. And so you are going to want to be very nice and methodical about this. And I look at it and I see root 10 divided by root 2, and I see that 10 and 2 are divisible by each other. So you can divide those two numbers and you would get root 5. All right, root 18 divided by root 2, they are divisible of each other, so I can simplify and get root 6. All right. In this example, root 18 all over root 2, I can simplify, and I get root 9, which then is the whole number 3. All right, but what if I can't? What if I can't? I have a situation where I have 1 divided by root 3. Well, you can never have a radical left. When you simplify radicals, in simplest form, there can never be a radical in the denominator of a fraction. So in simplest form, you can't leave a radical in the denominator. So you have to do something called rationalizing the denominator, okay? All right, so how do we rationalize the denominator? Actually, let me move this up a little bit so you can see. So you have to rationalize the denominator, okay? All right, how do you do that? It's very simple. You're allowed to multiply 1 to any number, and it just makes the number a little bit different. In this case, the 1, you look at the denominator of the fraction and specifically at the root that's in the denominator. You take that and you multiply root 3 over root 3. All right, so then you multiply across. So 1 times root 3 is just root 3. Root 3 times root 3 is root 3 squared, or root 9, which you know is the whole number 3. So now we've actually put the radical in simplest form by getting rid of the radical, the root that was in the denominator, okay? All right, now I want you guys, let's try another one together, and then you try. All right, so 2 divided by root 5. I look at it, 5 can't go into a whole number, root 5 can't go into a whole number, so I'm going to rationalize it. So I'm going to multiply by root 5 over root 5, and then I'm going to multiply across. So 2 times root 5 gives me 2 root 5, and root 5 times root 5 is going to give me 5. And there, that's a radical in its simplest form. All right, so now I have root 7 all over root 8. Well, this one's a little bit trickier, okay? What this actually means is root 7 over root 8. Now, you could reduce root 8 if you want to, but you don't really have to. You can just notice that there's a radical in the denominator and rationalize it, okay? So we're going to get root 56 all over 8. But now I have to simplify root 56. And I'm looking for the largest perfect square in 56. Cutting 56 in half, I'm about 25, and I know 25 doesn't go into 56. I look to check if 16 does, it does not. I look to check if 9 does, it does not. So then I can check 4, and 4 does go into it. 4 goes into it, so it's the square root of 4 times the square root of 14, all over 8. Okay, and actually I'm sorry, but I have to come over here. Okay, so the square root of 4 is 2, so I have 2 root 14 all over 8. All right, the 2 and the 8 are whole numbers, so I can simplify them like I normally simplify fractions. 2 goes into both of them, so I'm going to divide. And so my final answer would be 14, root 14 over 2. All right, so all of these, it's really just how they look. You don't want them to scare you. All right, let's look at this next one. I'm going to switch colors. 9 root 3 over 24. All right, well, Coach Fred isn't going to just jump to rationalizing. She's going to look, and I notice that 3 does actually go into 24. So I'm going to simplify that. It's going to become the number 9 all over root 8. Now I'm going to rationalize it. So I multiply by root 8 over root 8, and I get 9 root 8 over 8. All right, now I'm going to be careful because I know root 8 has a perfect square in it. 4 is a perfect square. So if I and I want us to do that in our head, root 8, you need to know, is 2 root 2. So I'm going to get 9 times 2 root 2 all over 8. And I see that 9 times 2 is 18. I am going to simplify the 18 and the 8, and I'm going to get 9 root 2 over 4. 9 root 2 over 4. Okay, last way. I've got mixed numbers. Well, you can't really multiply mixed numbers, so you can't multiply mixed numbers that are radicals. You have to turn them into improper fractions. So let's do that. So you've got 3 root 7, 3 and 3 sevenths, so that's going to be 24 over 7 times 7 thirds, and they are roots. Now again, I am going to simplify before I do anything with rationalizing and multiplying. Remember, simplify then multiply, simplify then multiply. The same rule is going to apply here. So I looked and I said, well, 7 goes into 7. And 3 goes into 24 8 times. So these all reduce to the number 1. So I'm actually left with root 8. And root 8, you should at this point know, is 2 root 2. Okay. We're almost there, guys. What I do want you to do is I want you to try the next 1, 2, 3, 4, 5 examples on the next page and bring them to class tomorrow. So do your best and try. All right, so these examples. Okay, so the last thing I want to go over is the distributive property in radicals, okay? So right now we're going to look at the distributive property in radicals. I know I'm going to be using the distributive property because I've got parentheses with addition and subtraction in it. So this is just like our normal distributive property. I'm going to multiply the root x to the 6th and to the root x. So root x times a whole number 6 is actually going to give me 6 root x. And then minus. Root x times root x is root x squared. Remember, that undoes that, so it's x. And that would be in simplest form. All right, let's try another one. Root x times root x to the 5th. All right, so we follow the same rules of exponents. It's going to become root x to the 6th plus 7 root x. Okay? Now I have to simplify x to the 6th. We take 6, we divide it by 2, we get x cubed. It's a whole number. The root's gone away. So I have x cubed plus 7 root x. Now you can't do anything with that because they are not like terms. Root x and x cubed are completely different. All right, so I left you 2 impress me's. The 2 impress me's are worth 5 stars tomorrow if you can get them. They have to be in their simplest form. And let's see what you can do. Hopefully you have a great night, and thanks for watching.